This is number 17 from sections 4.3 and 4.4. It says use the formula A equals P times 1 plus R over N to the NT to determine how long it will take a sum of money to triple if it is invested at 6% compounded daily. In the given information, we have our interest rate, which is 6%. Written as a decimal, that's 0.06. We also have the number of times a year that the interest is compounded. And so if it says daily, that's n equals 365. So our equation becomes A equals P, and I'm still going to call it P for now, times 1 plus R, which is 0.06, over n, 365. And then that is raised to the 365t. Okay, we do not know the initial investment, and therefore we don't know the later balance, but we do know this relationship between the two, that one is 3 times the other. And so we're going to say that the future balance is 3 times P, 3P, and you could have used, say, $100 for the initial investment and then $300, and you still end up with this factor of 3 on the left. So 3 equals the quantity 1 plus 0.06 over 365 to the 365t. And we can solve this using a logarithm. And so we'll start by rewriting the equation in logarithmic form. So log, the base of the power is the base of the logarithm. So we're going to put this 1 plus 0.06 over 365 as a subscript. Notice I didn't add the 1 and the 0.06 over 365 on my calculator, since we would end up rounding the decimal at some point, and so it's best to just leave it as an exact value for the base. And then the argument of the logarithm is the 3, and this is equal to the exponent, or 365t. Lastly, divide both sides by 365, and we get this expression log base 1 plus 0.06 over 365 of 3 divided by 365 is equal to t. We can first enter the logarithm on the calculator. If you do have the log base feature under math, you could use that to enter the logarithm directly. Otherwise, you're going to use the change of base formula, where you enter log of the argument, log of 3, divided by log of the base, and that's log of 1 plus 0.06 over 365. We're then going to divide that result by 365, and we get about 18.31 years. Another option is to solve this equation graphically. On my calculator, I have entered the power, or one side of the initial equation, in y1 and 3 in y2. Then graph, maybe using the standard viewing window, so I just pressed a zoom 6. And we see this exponential curve, and then this line at y equals 3, we want to actually view the intersection, which is a little bit farther right. So under window, I'm going to adjust my x max to be, say, 20, and then hit graph again. And then using the intersect feature that's under second trace, number 5, then hit enter 3 times, and we again see this 18.31, which is the number of years it will take for that investment to triple.